So we are now talking about limiting reagents. Much more of a real-life scenario, because no matter what the commercial product is or whatever the chemistry is, you never have the exact amounts of all the reactants, so they all react up and you make product. There's always some waste. Something's going to react up first. And once that reactant is gone, all the other reactants are just sitting there, right? So the reaction has to stop. The amount of product is formed. There's nothing you can do about it. So that's really the goal today, is to handle these limiting reagent problems, they're called. Okay. Okay. So I don't think this is a Minnesota thing. You guys go camping and make s'mores in Texas, right? Okay, so this is how I make the s'mores. I like a lot of marshmallows and the complete chocolate bar, no breaking it, right? And 2 of those full graham crackers. But out of that, I guess you get 2 s'mores, and I can break it in half and not be such a pig. Okay, so this is what I brought. 18 graham crackers, 90 marshmallows, 7 chocolate bars. And what's in purple is the recipe. Okay. So theoretically, Megan, can you do this in your head? How many s'mores could I make with this mess of stuff? For example, if I have the 18 grams, I could get how many s'mores out of that? 9. Get 9, right? The 90 marshmallows, I could get 10. The 7 chocolate bars, I could get 7. So what would be the answer? Oh, that's right, times 2. So it's really times 2 times all those answers. And now I got to do them all again. But pretty much it would be 14, 18, and 20 or something that we would have come up with. What would be the answer? It'd be the smallest one, right? It'd be the 14. So whether you can do that in your head or not, it kind of makes conceptual sense. But once you start putting in the word grams, everything goes out the door and we just totally forget how the heck we just solved that problem. So we have to do the whole box thing and do the whole converting and just get used to it. Okay? Like we have 18 grams. Stephanie, I've called this the mole bridge. I want to convert my answer. I want to get s'mores here, and we're going to pick our smallest answer. That's what we did. But what mole bridge am I going to put in here to convert to s'mores? 2 grams, and the 2 grams has to go on the bottom. And then up on top would be 2 s'mores. All right, so you end up with 18. That's how I think before someone knows we forgot to multiply by 2, so we had 9, and we're off by 2. But 18 s'mores from the grams. The marshmallows, all right, that mole bridge, Ashley, would be what?
2 s'mores over 9.
Perfect. 2 s'mores over 9 marsh. All right. So it's 180 divided by, hold on, what the heck? You have 90 marshmallows? Really? That's a lot. Oh, 90 divided by 9 is 10. Sorry, I can't even do numbers in my head. 20, and then the last one was 7 chocolate bars. And what is it? It's a 1 chocolate bar for every 2 s'mores. So then you get 14. And we need to pick the smallest answer, so the answer is 14. So we got it. All right, we got it. 14 is the answer. So some terminology. The limiting reagent. Dylan, what would be the limiting reagent in this s'more issue? The chocolate bars. Good. The reagent is another word for reactant, all right? So the limiting reagent is going to be the chocolate bars. It's the one that gave us the right answer. So the chocolate bars. All right? Because it's this guy. That's the limiting reagent. The guy that gave us, the reactant that gave us the smallest answer. Theoretically, how many extra marshmallows are there? Kenneth, how would you handle that issue? Theoretically, how many extra marshmallows are there?
Multiply the number of marshmallows that is needed to make 2 s'mores, and multiply that by 7.
7.
Then you subtract that from the marshmallows you have, so 90 minus 63.
So you came up with an answer of?
27.
He says come up with an answer of 27. Right? I don't know. For me, I pretty much have to do this ratio thing. Because I just don't like to, it's so much easier. I don't know, he might be right. Remember that number, Kenneth? Okay. How I handle these is, and again, it's going to get much uglier with grams. How I handle these is once you figure out what the limiting reagent is, use the limiting reagent for all calculations. And I didn't quite follow Kenneth, but maybe that's what he was doing in his head there, right? But the point is use the limiting reagent for all calculations. So if we use the limiting reagent for all calculations, we'll start with the 7 chocolate bars, convert it into marshmallows. And that'll be the marshmallows that are extra or the marshmallows that were used up? Used up. And then we'll do the subtracting thing that Kenneth was talking about. All right, so if you start with the 7 chocolate bars, now my mole-bridge ratio, which one would I pick? Emily, which one would I pick? The 1 chocolate bar for every 9 marshmallows. But the 1 chocolate bar has to go on the bottom, right? Otherwise it won't cancel. Well, that's where he came up with that 63. Did you hear? I remember him saying that, right? So then we ended up with 63 marshmallows. Right. And then he said, do you remember that? He said you got to subtract it from the number that you had. He nailed it. So 90. So that's, but the point is these are the marshmallows that reacted. Right? Because all those 7 chocolate bars, all of those reacted. So all those 7 chocolate bars reacted, so that means all of these marshmallows reacted. Make sense so far? And then, okay, if that's the number that reacted, how much is left over? Well, 90 minus 63, I think that's what he said, 27 are left over. Right? 27 are left over. Okay. So that's how you play the game with, and they're going to do that. They're going to ask you how much of the other reagents are left over. And we'll just have to remember, use the limiting reagent for those types of calculations. And then subtract it from the initial amount that was there originally, just like the s'mores. Another term besides limiting reagent, Connor, is theoretical yield. So in this s'more issue, what is the theoretical yield of s'mores produced? What do they probably mean by that? A yield is how much you get. 14. It's got to be one of these. All right? How much did you get? Well, you don't have enough stuff to make 18 and 20 s'mores. The chocolate bars all run out when you get 14 of them. So the answer is 14. Whoop. Theoretical yield is 14. if 7 s'mores, let's get rid of that one. If 7 s'mores were actually made, what is the percent yield? Another term. But we need a little expression to calculate percent yield. It's the actual yield, which you got, divided by the theoretical times 100. So the actual, this has to be given. What's there to give? Well, geez, it's a campfire. It's just dark. You dropped one of the chocolate bars. And Lauren is really picky about stuff that falls on the ground, and she won't eat it. So you got to, I don't know, throw it away, throw it in the fire or something, right? So you really only had 6 chocolate bars. So you only got 12 s'mores. So the actual is the experimental. Not everything's perfect. So it's always smaller than the theoretical. It's always smaller. But they have to give it to you. You don't know what the heck came up with the experiment. So divide the actual by the theoretical, and you get 100. So theoretical yield for if 7 s'mores were actually made, well, the percent would then just be the 7. Theoretical, we said, was 14 times 100, 50%. Okay? So the game's not so bad. The game's really not so bad. Just realize if you have 3 reactants, it's 3 times the work that we did in class last time, because you have to calculate an answer for everything. Okay? Alrighty then. So it'll be more fun if you guys do these than watching me do them. So let's go to the boards and see if we can knock some of these out and get a good handle on it. Okay. So here's our first one. We'll just spread out as much as you can. So we have 24.2 grams of ammonia, or NH3. It reacts with 32.6 grams of oxygen. Whoop. So first they want you to determine the limiting reagent and the theoretical yield for the production of water. Okay. So what's the game plan here? What's the game plan here? They gave you both reactants. Convert both those reactants to what? Like convert the 24.2 grams of NH3 to, in the end, grams of what, Stephen? Grams of, what are they after? They're after water. So we need to convert the 24.2 grams of ammonia all the way to grams of, everybody? Water. So that'll be one thing you got to do. But you don't know if that's going to give you the right answer. So convert the other guy. 32.6 grams of oxygen, all the way to grams of water. And the one that gives you the smallest answer will be your limiting reagent. Your smallest answer will be the theoretical yield. Yep. Okay. So remember, first thing you got to do is convert to moles, so then you can use the mole bridge. And if you like, I like putting in all the units first and put in the numbers later. I think it's faster, but it's up to you. And they want the theoretical yield in grams of water. So you have to go all the way to grams of water, don't stop at moles of water. So remember doing this? Right? So I would just copy these units. GNH3, GNH3. It might even be easier than putting, otherwise you get confused. I would put in the GNH3, mole NH3. And that's always going to be molar mass, right? And then just keep going though. And then this has to go down here. Then you have to use that mole bridge to get it into moles of what we're interested in, which is the H2O. Okay. But if you stop here, you're in moles of water. So you keep going. And then you go, okay, molar mass again. Mole H2O, GH2O. And the reason why I think this is easier, I mean faster, is because you have to find molar mass. So you use the periodic table. And here you have your calculator. Do the same thing here with this molar mass. You're all good to go. And then you look at the mole bridge to put this thing in, and you're done.
So that would be 17 though, right?
Yeah, that'd be 17. And this is always a 1 for molar mass.
Okay. And then it's right here.
That's from the reaction. You have to look at the reaction to get it.
Okay.
What is it? 4 ammonias for, what does that say? How many waters?
Oh, 6.
6, yeah.
So it'd be 6 over 4.
Yep.
And then you find out the H2O grams.
And then your smallest answer is the what yield? Theoretical yield. And what's your limiting reagent? The oxygen, yes. So identify the limiting reagent and identify the theoretical yield. You got about 38 for the ammonia. For part B? Oh, for example 2? Yes, it is. It is asking for the opposite one in EX2. And what did you guys get for the next one? 38 and about 22? Okay. So hopefully you got about 22 grams for the theoretical yield of water. And then you identified oxygen as your limiting reagent, right? Those are the two answers that it wanted. It wanted theoretical yield and determine limiting reagent. So you have to say somewhere O2 is a limiting reagent. So those are the two answers that it wanted. And then it wants you, in part B, get the percent yield. So divide the actual over the theoretical times 100, and Emily got what? 81.7%. 81.7%? Okay. Okay? Good. Try the next one then. If you got it, try the next one. Yep.
So with this one, how do we write this? Do we just pick either one of these to put there, or? Because when it says a mixture of 30 grams and then 30 grams, what do we do here?
Well, there's a number. Does anybody have a game plan for EX2? There's a number of things you could do, right? You could, one game plan is just to handle all these problems the same. So you just kind of pretend that it wants to know how much CO2 there is, right? It doesn't even matter. You pick a product. And then you convert both of these to CO2. That way you can determine which one's a limiting reagent, right? So it's going to be a two-part question no matter how you handle this. There's no way to get about it. There's going to be two calculations. The other thing you could do is you could convert the 30 grams of CS2 into grams of oxygen and see how much you need. And if there's more than 35, whoops, we don't have enough oxygen. Oxygen's got to be a limiting reagent, right? So there's two ways to go about it. Seems to me, since you have to do two calculations, you know, it really doesn't matter how you go about it. The idea is you have to use the limiting reagent for all calculations. So you got to find out which one is the limiting reagent. So conceptually for us, since we're just beginning, I think it makes most sense just to pick something like CO2. And you don't even need to go to grams of CO2. Just go to moles of CO2. Convert both of those reactants to moles of CO2. And then you'll figure out which one the limiting reagent is. Right? I think that'd be the easiest. So that'll be my game plan for this. And you can go all the way to grams of CO2 if you want, but you really don't need to, because you're just trying to find limiting reagent. See if you can find it, and then you'll know, and then you can figure out the rest of it. You can stop right here, Paul, if you want, because you're just going to pick your smallest answer anyway, right? So you just stop right here, and you get moles of CO2 and compare the moles. Okay, anybody get their moles if you went that route? You got 0.364 when you had the oxygen, is that right? And then if all the carbon disulfide reacted, you got how many moles of CO2? 0.39? Okay, did you get these numbers if you did this route? Does everybody agree who did this route? You got 0.39 moles of CO2 if all the carbon disulfide reacted. If all the oxygen reacted, you got 0.364 moles of CO2. Okay, so whether you did it this route or not, just see if you can conceptually follow. So which one is my limiting reagent? The oxygen's my limiting reagent. Okay, so O2 is my limiting reagent. So the grams of O2 that remain equals how many? Oxygen is my limiting reagent. How much of it is left? out of that 35? It's the limiting reagent. Go back to the chocolate bar idea. If chocolate bars were all the limiting reagents, you make all your s'mores, how many chocolate bars are left at the end? Kendall, how many chocolate bars are left at the end if you used up all your chocolate bars to make s'mores? Right? The limiting reagent always has how much left at the end? 0. There's never anything left for limiting reagent. It's the guy who disappears first. So the grams of oxygen that remain is 0. That's how it always worked for limiting reagents. So now if you want to get the grams of carbon disulfide that remain, let's convert those 35 grams of oxygen all the way to what? Convert it all the way to grams of carbon disulfide. And is that my answer? No. I have to do what? Subtract it from, that 30. Whatever I get here had better be less than 30. Otherwise, I really screwed up. Right? This has to be less than 30. Okay. So I guess you could say then subtract from 30. Okay? So see if does that make sense to you? Use the limiting reagent for all calculations. No matter how you go about it, figure out who the limiting reagent is, which reactant reacts up first, and then use it for all calculations, whether it's theoretical yield or if you need to know how much of the other reactants left over, always use the limiting reagent. Actually, I added another one.
Sir, you got it.
Look at all that empty space. So I
I
added another one. Okay. Yes. Okay. So first you converted both of these to moles of CO2, and then you picked your smallest answer. So this, in theory, is how much CO2 you could get. We really don't care. We're interested in these reactants. So if this gave the smallest answer, that means all of this has to react. Because this is going to be stuff left over. This can make more. So this is all gone, 35 grams of oxygen. Limiting reagent, 0 grams left, because 35 minus 35 is 0. Okay, now we want to know how much of this stuff is left. We use limiting reagent that we identified for all calculations. So let's convert this all the way to grams of CS2. And we're going to get 26 or something, I don't know. And then subtract 30 minus 26, you say, hey, there's 4 left over.
Oh, okay.
So you could also start from here, too, because this is also a good answer. You could start with the 0.36 moles of CO2. It doesn't matter, as long as you use this number or that one.
Okay, well, I'll just stick with this one.
So I don't know if you guys realize, did you realize that you could have used this answer, too, to get the correct answer? Because that's your theoretical yield. You could use this and convert that to grams of CS2. And that'd be the grams of CS2 that reacted to make this. Okay? So you could use that too, but it seems easier for me just to always use limiting reagent. Okay? Plus 3 moles. What's the molar mass of carbon disulfide? 32, 64, 76. So keep going. Try the next one if you got an answer here. So did you get an answer like around 0.3 grams left over? Somewhere around there. Depends on the rounding. No? Oh, so did I do my... You didn't get 27.7? Oh, see, I can't do shit. God. See how I can't do anything in my I can't do anything in my head. Dylan is so sad. So it should be 2.3, right? That is so sad, isn't it? So you should get 2.3. So keep going.
Why did you choose to go to CO2?
Oh, it didn't matter. I could have picked anything. I could have picked this guy.
Okay,
I could have chose to go to grams of CO2. I just picked a product because then it fell into the same game plan as one of these, or the s'more issue.
So right here, it doesn't matter which
It doesn't
one?
matter what
Okay.
you pick. Yeah.
Okay, I was just like...
Yeah, I was just randomly picking something.
So, sir, what did you add?
Oh. I thought I did. Oh, I didn't add. You already done with EX3? Okay, I gotta give you another one then.
Oh, wait, we didn't have B, sir. You added B.
Oh, I added B. Oh, okay. There's a part B to EX3. If you're flying through this, and that part B I added in the morning. So if you're not sure what's going on here, now's the time to ask.
And this one? Why did you use 35? Why did you use like 32? Or could you have used either or?
Oh, because
Because
you
this one was
drew
the
this one. He gave the smallest answer.
Yeah.
So I know this is the amount of CO2 that's going to form in moles. So that's really my theoretical yield, but it's in moles though, not G's.
Oh, I'm sorry.
It's in moles. So I can use this to convert to how many grams of each reactant remains. So first let's think of the oxygen. All of that's gone because that gave my smallest answer. So there's 0 grams of oxygen left over. He's all gone, just like the chocolate bars. Okay, that means there has to be some of this left over. How do you figure it?
Oh, by using this one?
But yeah, you can convert all this to
Then
grams
just
of...
go to the smallest one and then-
Yes, he's the limiting reagent. So think of whatever the product, theoretical yield, what gave the product, limiting reagent. Is this making sense, Stephen?
Yes, sir.
Excellent. You guys know what you're doing? Does this make sense, Rebecca? Did Giselle make sense?
Yes.
Okay. So there's try a few more of these. Especially part B I added. There's a term that's in your homework. All right? And make sure you see what I'm talking about here. Like part B has the term excess reagent. Yep.
And A, is this all we have to do? Would that give you grams of HNO3?
Yeah.
Just to
We're
do...
going to produce a mixture of 2.1 grams of NO2. Well, you're going to have to do it twice, though.
Yeah, I did the NO2 and the H2.
Yeah. And then you pick your smallest answer.
And then that's it.
And that's it.
That gives
Yeah.
you grams. Okay.
Yeah, because you converted all the way to grams.
Okay. Yeah.
What'd you come up with? 1.97 grams of... I don't know. Looks right. I don't know what they answered. You have to see what someone else got. So, we'll see if anyone else agrees with you, Connor. 1.9. Did anybody else get 1.9 for part A as a final answer? Okay, good. Connor, that's right. Okay. And there's one last part, part B. And part B I added this morning. Did you see how we got the final answer for part A?
Yeah.
Yeah. And then you had to do this again for the other guy. 2.29 grams of water, and pick your smallest answer. So everyone's clear on what, in part B, the excess reagent part is? It's just another word for what? Bowdy. It's another word for what? Yeah, the leftover guy. Exactly. The reagent that's not the limiting reagent, the other one. So it's just like the problem we did before, EX2. So part B is just like EX2. And you can just pick any product, figure out what the limiting reagent is, save a little bit of time, just go to moles maybe, right? But either way, you'll figure out what the limiting reagent is. Part B would have been really easy and really fast even if it would have just asked for how many grams of what reagent remain. Not the excess, but the limiting. Yeah, you could just say 0, but life isn't that easy. See how to handle that, Mia?
I'm still trying to figure out how to do it.
How to do which part? Part A or B?
B.
Part
yeah.
B?
Yeah.
Okay, so for part B, what I would do is, see, we're used to picking the smallest answer.
Yeah.
So to find out what the limiting reagent is, so I would just do that for part B again, and just pick, I don't know, pick NO.
Okay.
It doesn't pick what,
Just
doesn't
pick
matter
any
what
one.
product you pick.
Okay.
Just pick one of them, and you don't even need to go all the way to grams of it. You can go to stop at moles.
Yeah, like we did the last
Yeah, like you did the last time. And then just your smallest answer will be the limiting reagent one. So in part B, just pick a product, right? And convert to moles of that product to save yourself a little bit of time. Lorena, did you do that?
Are we supposed for, because like NO2 there's none left, right?
For part B, that's a different mixture though. They have 42.1 grams of NO2 and 43.6 grams of water.
Oh, so it's like the
So you
same
have
as
to,
the first one, but it's
yeah, it's gonna be the same as EX2. So you got to convert both of these to, I'll pick NO or something, right? I'm just gonna pick NO, and I'll stop at moles.
So can we stop at girls or it has to be?
You can stop at moles because you're just after identifying the limiting reagent. So in part B, did anybody figure out what the limiting reagent is? Anybody get an answer? Okay. So that's a theoretical. You went to. Okay, so the guy that gave you the smallest answer. So you compared the 42.1 grams of NO2. Oh, no, hang on, no. You got the 42.1 grams of NO2, and you got 0.3 moles of NO, and the other grams of water, you got 2.4. Let's write those down. This is what Paul got. When he got the 42.1 grams of NO2, you got, I forgot, 0.3 moles of NO? Is that right? And then the 43.6 grams of water, you got 2.4 moles of NO. Okay, did anybody else get that? Oh, great. Okay, so what is your limiting reagent? The NO2 is the limiting reagent. Okay, if you did it Paul's way here, this guy is your limiting reagent then. So your excess reagent is water, H2O. That's your excess reagent. So convert your limiting reagent. So the last step, right? Convert the 42.1 grams of NO2, your limiting reagent, all the way to grams of H2O. Is that your answer?
No.
No, that's the grams of water that reacted. So subtract that from 43.6. All right. To get your excess. Okay. So we're about out of time, but I think you got the idea. Okay, so write down all your units when you're working these out because things will be much less frustrating.